So this is the review that uh, is the Eggspert review instead of the grade papers around the room. So this one, find the 115th term of the sequence. So because here it is not not growing very much, it is adding, and in this case it's adding 5 every time. So we know the pattern is adding. If we want the 115th term, we're going to need explicit sequence. So we're going to have fn equals adding first term, we're adding 5, and repeated addition is multiplication, so we'll have n minus 1 that's multiplying. And if we put in 115 in for n, our our answer is going to be 572. 4 people got a chain email that said send to 7 people, so you won't have that luck. If they send to 7 and those sent to 7 each, then it's 4 people. They each sent to 7. And so it's starting with 4 people. And then if each of these sent to 7, then there's 7, 7, 7, 7, which it would be 28. And then those 28 sent to each 7 people. And so what's it doing here is it's actually multiplying by 7, so times 7 again. So this is geometric. So if we want the explicit form, we're going to start with the first term is 4. It's multiplying by 7. And repeated multiplication is exponential, or you use exponents. So it's n minus 1 as an exponent. Find the recursive form of the sequence. So that means that we have to figure out what is this doing here. And since it's growing really, really fast, I'm thinking that's probably geometric. It's not adding, because if you add, you'd add 54 to get to 63, but if you add 63 and 54, you do not get 441. So this is multiplying, and this one is multiplying by 7, because I know 9 times 7 is 63, and the pattern continues. So if I want recursive form, well, all I have to know is it's multiplying by 7. So we would have fn equals 7 times fn take away 1. Remember, this fn take away 1 is the previous number, whatever it may be. It's the previous number, previous term. The common difference, d, which is also known as the slope. So on this one, if you want the common difference, or how many is it adding, since it's going up and not, it's getting less negative, that means it's going up. So this was adding 13, I think. So then we want just the common difference, so our common difference is just 13. Marnie decides to start getting her grades up. She's going to do 10 minutes of homework on the first day, and she's going to add 5 minutes each day. The explicit form for that. So this is arithmetic, since it says it's adding 5 minutes on every day. And the day 1 is 10 minutes, so it's going to be 10. It's adding 5 every day, and then n minus 1. Use the perimeter. What will the perimeter in the 19th figure be? So in this one, here it's adding 3 and adding 3. So I could just keep adding 3 until I get to the 19th one, or I could say the first term is 8 plus 3 and then n minus 1, and I could plug in 19 for n. And if you actually do that, the answer is 62. What is the fifth term of the sequence defined by the recursive rule? F of 1 is 7, f of n equals fn minus 1, take away 5. So what's this saying is you want the fifth number, and the f1 is 7. That means your first number is 7. And again, this just means to the previous number or to the one before, you're going to take away 5. So to the 7, I'm going to take away 5. So that's 2. Take away 5. Negative 3. Take away 5. That's negative 8. And I do it one more time, and it's negative 13. So that's the 5th term. Is the graph arithmetic or geometric? Well, it's definitely not a straight line, so it's definitely not arithmetic. This is geometric. And that's it. Find the next term in the geometric sequence. You know it's geometric, therefore it is timesing or dividing. The numbers are getting smaller, so I'm going to say divide. And I really don't remember what this is. Maybe it's 6, 12, carry the 1, 24, 25. Okay, so I'd say it's dividing 6, but it's actually going to be a negative 6 because if I divide a negative and a negative, I get a positive. And then positive divide negative, I get a negative. And then if we divide it one more time by a negative 6, I'm going to get a positive 7. And that's the next term in the sequence. Which of the following is not arithmetic? Well, this one is, it looks like adding 3, and that stays the same. This one, taking away 2. This one, that's actually taking away 1.5. And this last one is doubling. That means it's timesing by 2. So that is not arithmetic. To decide if it is arithmetic or geometric, Amy puts 6,000 into a savings account that earns 3.5%. Anytime you've got percent of a number, you're timesing it. And in this case, it's actually 6,000 times 1.035 is actually what it'd be multiplying by. So each year. And so this one is going to be geometric. Teachers start at $30,000 each year, and they get 500 additional salary. Well, additional, they're adding 500 every year, so this is arithmetic. Sam has 546 candies, and each week after eating the candies, he has 90% of them left. So it's 546 times 90%. Anytime you have a percent, you're taking a percent of something, which is multiplication. And then, so that is geometric. For Rachel's challenge, Tim is going to compliment 6 people. So again, you've got Tim, 1, 2, 3, 4, 5, 6. And then it says each of those people are going to compliment 6 of their own people. So we're going from 1 to 6 to 1, 2, 3, 4, 5, 6, and each of those 6 are going to get 6, so that's 1, 6, 36. It is multiplying, therefore it is geometric. Write the explicit formula for the nth term of the geometric sequence with f of 4 being negative 84. That means 1, 2, 3, 4, negative 84. And a common ratio of 2. So if I want the explicit formula, it looks like this in a geometric sequence. R is 2. I'm timesing by 2. But in this case, my 4th term here, I need my first term for this one. So if I go this way, I would be timesing by 2. But since I want to go backwards, I'm actually going to divide it. So I'd have 42. Divide 2 again. I'm going to have negative 21. And then if we do it one more time, it's negative 10.5, which is the same as negative 21 halves. So if I like the fraction version better, so this would be Fn equals negative 21 halves. It's timesing by 2. R is 2. And then n minus 1 for the explicit form. An arithmetic sequence has the first term of 2 and a seventh term of 17. Right away, I have 2 points, or 2 terms. If I have 2 terms, I'm going to make a table and find what it's going by. So this is 15. This is 6. 15 divide 6. I don't really know that. So 6 goes in here twice. With 3 left over, 6 goes into 35. So it's 2.5 for our slope. And so we're going to, I have Fn equals, my first term is 2. It's adding 2.5. And then n minus 1. In this one, it says we want the output to be 57. That means I want to plug in a number here, and I want it to equal 57. So in this one, that number turns out to be 23. If you plug in 23 there, you could just keep adding from the 17. So another way to do it is, yes, you know the seventh term is 17, and you could just keep writing out the term numbers until you get 57. Or another way to do it is plug in numbers and see what works. What is the fifth term of the geometric sequence in which f1 is negative 3 and fn equals 6, fn minus 1? So we have 1, 2, 3, 4, 5. It says the first term is negative 3. And so this tells us the first term is negative 3. And then this tells us that we're going to take the 6 and we're going to multiply it to whatever term is in front of it. So I'm going to multiply 6 the whole time. So 18, negative 18, because it's negative. And then we just keep timesing by 6. If we do that until we get the fifth number is negative 3,888. Here we need to make a table, a graph, and an equation. So we got 3 dots, 9, and wait, this is 6, I think. 1, 2, 3, 4, 5, 6. Okay, 6, and then this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on our table we go 1, 2, 3, and 3, 6, 9. So make my graph 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3. 1, 2, 3. Over 1 up 3. Over 2 up 6. 6. And then over 3 up 9. And we get this nice straight line. Because it is arithmetic, right? If it's adding, we're going to get a straight line. And it's adding 3 in this one, so our equation, or the explicit form, is going to be the first term. It's adding 3, and then n minus 1. You could actually simplify that if you distribute. And the 3's actually cancel, so it's really just 3n, but either way is fine. Here we've got 3, then there's 6, then there's 12. So there's 1, 2, 3, 3, 6, 12, 2, 4, 6, 8, 10, 12. And then 1, 2, 3. So I go over 1 up 3, over 2 up 6, and then over and up to 12. And notice that this is not a straight line, it curves because it is geometric. This is multiplying by 2 every time. And you can see that in the pattern. It takes what we started with and it doubles. So the equation is Fn. The first term is 3. We know it's doubling or timesing by 2. And when we're repeated multiplication is exponents. So that's 2 to the n minus 1. Macintosh picks the same number of apples every day. After day 5, he has 31 apples, and after day 9, he has 59. Well, I've got days, and that's just the same as terms, so 5 and 31. 9 and 59. So I need to find this number